So our next example will be sulfur dioxide. I'm going to clear my paper over here. And I'm going to start by determining which one of these is the central atom. It's probably sulfur because there's just a single sulfur atom. But if I wanted to check, I could look at the periodic table and I find that sulfur and oxygen are in the same group, right? So I'm going to have to use the method of there's only one sulfur atom. So that should be the central atom. I'm going to draw the S. I'm just going to space out the oxygens as far away from each other as possible. And then I'm going to connect them to the sulfur atom with bonds. So those are my first two steps. Do you remember the next step? Next, we want to calculate the total number of valence electrons that sulfur dioxide has. So I'm going to write the formula down here. And remember we said sulfur and oxygen are in the same group. So they actually both have 6 valence electrons. Sulfur has 6 valence electrons and oxygen has 6 valence electrons. So underneath sulfur, I'm going to put a 6. There are 2 oxygens, so I'm going to do 2 times 6. I always need to multiply if there's a subscript because that tells us there's more than one of that type of atom. And you can see that clearly in our diagram. So I have 6 plus 2 times 6. That would be 12 plus 6, which is 18. I already used 4 electrons in my drawing, right? Each bond represents 2 electrons. So that means I still have a lot of electrons left to use. 14 electrons left to use. I can see that my oxygen atoms only have 2 electrons each. So I'm going to add 6 electrons to each oxygen atom. And that will use up 12 more electrons. I'm drawing them roughly on each side of the element so that there's 2 on the top, 2 on the side, 2 on the bottom, and then the bond. So I used up 12 more valence electrons, which means I have 2 left, and I can put those 2 around sulfur. Then we want to check and make sure each of the elements is achieving the octet rule. This oxygen has 2, 4, 6, 8 valence electrons, so it is achieving the octet rule. This oxygen has 2, 4, 6, 8 valence electrons, so it is achieving the octet rule. And then sulfur has 2, 4, 6. So I used all my valence electrons, but sulfur does not have what it needs, right? And if I wanted to double check, I could count up all the valence electrons here, 2, 4, 6, 8, 10, 12, 14, 16, 18. Those are all the electrons that I have to use. So a trick, if we run out of electrons, is to change one of our lone pairs into a double bond. Because bonds are kind of like having more electrons. So I'm going to change one of the lone pairs that was around oxygen to a double bond. I'm just going to put these dots back for now. Erase them by mistake. So let's see again. Let's make sure that we used 18 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. I used 18 valence electrons. This oxygen atom has 2, 4, 6, 8. This sulfur atom has 2, 4, 6, 8, because each line represents a pair of electrons. And this oxygen atom has 2, 4, 6, 8. So in this case, we have a double bond between one of the oxygens and sulfur and a single bond between the other oxygen and sulfur in order to use all the valence electrons and also for each element to achieve the octet rule. Try the next one, H2O.